All right, so what we're going to be doing today is we're going to continue our look at Chapter 5. So last time we introduced the idea of the true score versus the measured score. We also introduced the idea of reliability, that's how close you're getting to the true score, and also validity, that is whether or not you're actually measuring what you think you're measuring. So today we are going to continue on with our look at Chapter 5. We're going to do the library assignment feedback just real quick before we get going on that. And then we're going to talk about measuring variables and the different types of measurement scales that you need to be aware of, because some of those are able to do some things and some of these are not able to do certain things. So you always want to make sure that you know the measurement scale you're working with before you start doing certain operations with those scales. All right, so for the library assignment feedback, you got basically feedback like this in your Canvas assignment. So next to each question there, it indicates whether or not you got certain criteria correct. So the only thing missing from here is whether or not it was named according to the requirements of the assignment. That I think just about everybody did pretty well. But this will indicate whether you got the correct article for question number 1. For question number 2, was it recent enough? Yes. Was it a reconstructed memory article? Yes. Was it a primary research article? Yes. Weldon and Bellinger, did you find the correct one? Yes. And then for 4A and 4B, there's the feedback for A, there's the feedback for B. So again, question number 1, did you actually find the correct article? Incidentally, if you got question 1 or 3 incorrect, those articles are now available in the research paper resources. So just in case you got those wrong, you want to make sure that you're working with the correct articles so you can get those straight from Canvas in that folder. For question number 2, was the article recent enough? And if you mistakenly submitted the Roediger and McDermott paper for this, then you did not get any points for that question. Question number 3, was it reconstructed memory? Was it a primary research article? Question number 3, did you find the Weldon and Bellinger article? And then lastly, for 4A and 4B, was it either recent enough or highly cited enough? Was it a group memory article? Was it a primary research article? And then the same thing for 4B. So that gives you your feedback. Days late, in case you handed it in late. And then your final grade was basically your percentage with 1 point for each yes. So there were 16 points in total for the assignment. So just depending upon which criteria you fulfilled. And that also included your late penalties. So for those of you that did perfectly on the library assignment, you're done. Your articles have been approved. You are ready to go with your background readings for your research paper. However, if you received a no for any of those questions, so only question 2 and 4A and 4B, only if you received a no on any of these criteria or in any of these criteria or of any of these criteria. So for example, if this was your feedback, you have no's for 4A, not a primary research article. You got no for 4B, not a group memory article. If that's the case, you need to resubmit a new article for that question. So we need to make sure that we have enough of a background literature review. We have enough primary research sources in order to write our research paper. So we need 6 articles in total. The Deese article, Roediger and McDermott, Weldon and Bellinger, those are the 3 everybody shares. And then the 3 additional ones from 2, 4A, and 4B that you find on your own. So again, if you take a look at your feedback, if you received no on any of those, you need to submit a new article to be approved for writing your final research paper. So again, 1 more recent primary research article regarding reconstructed memory, or 2 more highly cited or recent primary research articles regarding group memory. And just to be very clear on this feedback, most of the recent and highly cited ones, or the recent articles, most people got that correct. For the group memory article, a lot of no's occurred here. What that means is that even though your article mentions the word group, it's not about group memory, it's not about group cognition, It's not about people learning together and or trying to remember things together. So for example, there were studies about fMRI studies where there was like a schizophrenic group and then there was a controlled group. And while that did have things to do with memory, it wasn't group memory because they were learning the information individually. They were then tested on the information individually. So that's not a group memory article. The other ones was primary research articles. Some of these were review articles that didn't have that method section with the subject characteristics. They didn't have that results section with the statistical jargon. And that's a secondary article. That's somebody else's opinion. As psychologists, as critical thinkers, we need to go back to the original papers. So that's why you might get a no here if you submitted, for example, a review article. So if that occurred, we need to find substitutions for your assignment, and you have to resubmit these for approval. So everybody needs to write their final research paper with their 6 articles approved. So again, everybody has Deese, Roediger, and McDermott, Weldon, and Bellinger. Those have been approved. Question 2, 4A, and 4B, you need to make sure that those articles are also approved. All right, so you'll need to resubmit those if you fall into that category. I'm going to, just to reiterate this, put in a new assignment tab, library assignment revision complete, just so you can keep track of whether you've completed your revisions or not, in case there's any doubt about that. So I'll update that either tomorrow or on Monday. And if you have to submit your articles for approval, you have 3 attempts to resubmit. So we're really looking to develop our skills in identifying information, our critical thinking skills about being able to know and weigh where information comes from. Is it a secondary source? Is it a primary source? And there's just no driving force to try to learn that if we have unlimited attempts. So if you're able to basically just send me 100 articles, just by chance, one of them will be primary research, and I have no way of knowing if you now know how to identify primary research or not. So we have the opportunity to grow those skills. So you got 3 attempts to resubmit information. So take your time, look at the article, read through the abstract, make sure that it's group memory, either learning in a group or recalling in a group. And the due date for these 3 attempts is October 28th. So that's over 2 weeks from now. So you have 2 weeks to find probably maximum 3 articles that you might need. For most of you, it's just the one. So make sure that you take advantage of that. And the reason that we're doing this is because we need that background information. We need that ability to go to the literature to write our research paper. And because of that, these articles, they are required for your research paper. And I just want everybody to be very aware that if your articles are not approved, so if you don't go through this process, then there are heavy penalties on the research paper for this. So this isn't to intimidate you in any way. It's just the facts that if you don't have the background information, you then cannot write a good, high-quality research paper. So that is in the research paper grading rubric that I use. So just be aware of that and make sure that you get those articles approved because there will be heavy penalties again on your research paper if you choose not to. And then also for the research paper, do make sure that you do use your approved articles. So you can use articles in addition to those, but you have to use the articles that you have approved. So I have made a list of everybody's approved articles. I will be looking for those in your final research paper. And again, if you decide not to use one of the articles that was approved, then again, there's heavy penalties on the research paper for not using those and substituting in your own alternative articles. Again, if you find new information, if you find new articles that you think to yourself, oh wow, this is great, this would really make my research paper stronger, by all means use them, but those are in addition to the ones that have already been approved. All right, so any questions about that aspect? The library assignment resubmissions? All right. So what we're going to do today is we're going to continue our look at Chapter 5. This is going to be the last lecture we're going to have prior to the exams. This is the last thing we need to know for exam number 2. And today we're going to take a look at measurement scales and the different types of measurement scales and what they can do. So we're going to look at measurement scales. We're going to take a look at true score and measured score and see basically how these different measurement scales all line up. So just to kind of recap what we did last time, the true score is the actual real score. And in psychology, a lot of times, this true score cannot be directly accessed. So as we saw last time, you cannot directly measure depression. You can't see depression. We don't have a microscope that lets us take a look inside a person's mind and see how much depression they have. But there is a true amount of depression that an individual has. That's the true score. The measured score is their score on, for example, the Beck's Depression Inventory that we have access to. And again, reliability and validity was all about how much does your measured score, in fact, measure your true score. We're going to see, however, there's another aspect to this, and that has to do with the relationship between your measured score and your true score. And what that's going to do is it's going to allow us to do things, or it's going to limit us from doing things with the measured score, depending upon that relationship. So in this class today, when we're showing the true score, we're going to visualize it, and the true score is always going to be in this solid lined box. The measured score is going to be in a dotted line box, just to keep those two concepts separately. But let's say that we were measuring something that is pretty easy to visualize. Say we were measuring people's heights. People have a true score on their height. So Shaquille O'Neal, new CEO for Papa John's, he has an actual true height. He's a certain height for real, and he has an actual height. LeBron James, got tired of updating his jersey. I don't know where he is right now. But anyways, LeBron James has a certain true height. And Muggsy Bogues used to play for the Raptors back in the early days. One of the shortest NBA players of all time. He has a true height. And if you were to put their heights on a scale, this is how their true heights would be distributed on that scale. So Shaquille O'Neal is just a little bit taller than LeBron James. And LeBron James is way taller than Muggsy Bogues. So this distance is going to be representative of the difference in the actual true score between these individuals. So far, so good? All right. That's the true score. This is their true heights. We can measure their true heights using a variety of different measurement scales. One measurement scale is to use a tape measure. You literally start at the bottom, you go up to the top of their heads, and you see how tall they are. And if you used that tape measure, you would find out that Muggsy Bogues was 5'3". If you used that tape measure, you would find that LeBron James is 6'8", and you would find that Shaquille O'Neal is 7'1". Importantly, the distance between the true height of Muggsy Bogues, the true height of LeBron James, and the true height of Shaquille O'Neal is reflected in the distance between the measured score of Muggsy Bogues, the measured score of LeBron James, and the measured score of Shaquille O'Neal. So we're going to see that this sort of parallel structure between the measured score and the true scores leads to very powerful measurement scales. All right, so it's all about the relationship between your measured score and your true score. Let's take a look at another way to measure height. We could measure height on a relative scale. We could just say, all right, I'm going to classify one of these players as the shortest, I'm going to classify one of these players as being in the middle, and I'm going to classify one of these players as the tallest. Note that this is a measurement scale. It's highly reliable. All of us are going to be able to say, yeah, Muggsy Bogues is the shortest. All of us would be able to say, yeah, LeBron James is in the middle. All of us would be able to say, yeah, Shaquille O'Neal is the tallest. So it would be highly reliable. it's also very valid. We think we're measuring height, and in fact we are measuring height. However, notice that there's no real distance between shortest, middle, and tallest in our measurement scale. So as far as these are three separate categories, they're equally distant from each other. But notice that for Muggsy Bogues, shortest to middle is a huge change in the real life, the true heights. Whereas from middle to tallest, it's a small little change. So a change in category is sometimes a huge change in the true score, whereas on the same measurement scale, a change in category is sometimes a very small change in the true score. So we end up with this not one-to-one, not parallel structure, and as we're going to see, that leads to a much weaker measurement scale. All right, so that's the kind of basic thing we're going to be looking at. What are these measurement scales, and what is this relationship between the true score, that actual real score, the concept that we're measuring, versus the measured score, the score that we actually have access to, the score that our scale tells us about? And what is the relation between your measurement scales and the actual truth? So whether it's this parallel structure here, or whether it's this skewed non-parallel structure here, that is the essence of what we're looking at today. So that relationship between the scores leads to four basic types of measurement scales. And those four basic types, in increasing order of power, in increasing order of things that you can do with them, are the nominal scale, and then after that we got the ordinal scale, and then that's followed by the interval scale, and then we have the top of the line, the best scale, which is the ratio scale. So again, all of these are measurement scales. They all have reliability, they all have validity like we saw last time, but you can do very few things with a nominal scale, and you can do a lot of things with a ratio scale. So the importance of being able to recognize these scales is a very important skill in psychology. All right, so let's start off with that nominal scale. The nominal scale is your basic scale. It's literally the lowest level of measurement that you can call a measurement scale. And on the nominal scale, what you measure and all you can say is that the categories are different. So you can place people in different categories, and that's it. There's no order to the categories. There's no value to the categories. It's just different categories. So for example, going back to our basketball players here, we can categorize these individuals as having different positions, right? We can categorize them as having different basketball positions. So Muggsy Bogues was a point guard, and LeBron James, I guess, was classified as a small forward. We got Shaquille O'Neal as a center, and actually it's a little bit misleading to have them in this order here, so let me just reorganize that, and we'll put them in a stacked orientation. And the reason that it's misleading to have them in order is because there's no order to these, right? So we can definitely say, yeah, Muggsy Bogues played point guard. That was his position. And we can definitely say LeBron James, yeah, small forward. That was his position. And we can definitely say Shaquille O'Neal, yes, center. That was his position. But there's no order to this. We can't say that small forward is more basketball position than point guard, right? We can't say that center is less basketball position than point guard. We can't put them in an order of basketball positionness. It doesn't even make sense in the English language. So while we are able to measure position, and again, highly reliable, highly valid, it doesn't have this relationship because this does not have any order. So while we can categorize things, we can't put them in order. That is your basic scale. That's a nominal scale. So in a nominal scale, all you can say is that the categories are different. Some examples of nominal scales are things like gender differences. You can put people in a category of male. You can put people in the category of female. But you cannot say that one of these is more gender than the other. You can't say that being female is somehow more gender or genderousness than being male, right? You can't put them in any order. You can definitely classify individuals, but there's no order to it. Categories are different, but without being able to say any more, that is a nominal scale. Undergraduate majors. So if you're an education psychologist and you're wondering what are the undergraduate majors that are getting the highest enrollment, you can classify people in terms of their undergraduate major. We can take a look at everybody in this classroom and say psychology major, and we can take a look at other people and say anthropology major, mathematics major, physics major. We can do that, but we can't say, psychology pride aside, we can't say that one of these is more undergraduate major. We can't say that psychology is more undergraduate major. We can definitely say that there's more people in that category, but it's not like the category itself is somehow more major. And one of the things that we're going to see that we can do later that we can't do right here is you cannot take averages of a nominal scale. So we would be unable to analyze IUSB and say, all right, 1/3 of the students are psychology major, 1/3 of the students are anthropology majors, and 1/3 of the students are mathematics majors. Let's say that was the case. In this case, the average major, if we add up all the majors and we divide by 3, it's a psychotropolomathematics major, right? It makes no sense. There's no average major in the university. So that's because undergraduate majors are on a nominal scale. You can't take averages for a nominal scale. Other things on a nominal scale, types of restaurants. So you can go to an Italian restaurant. You can go to a Japanese restaurant. You can go to a diner. You can go to a fast food restaurant. You can classify different restaurants very simply and very straightforwardly, but none of them is more restaurant. None of them has a higher degree of restaurantiness, right? We can't measure that because it's on a nominal scale. And then the last one, genres of movies. You can have a horror movie, you can have a romantic comedy, you can have an action film, and despite what you might think of one of those genres, you cannot argue that one of them is less movie than the other. So for example, Martin Scorsese literally just came out and said that the MCU isn't real movie making, right? That what they're doing shouldn't count as being movies. Basically, he's saying, well, we can classify those as genres of movies, and in my opinion, they're less moviness than other movies, other real movies. And it makes no sense. You can classify them as different, but they're on a nominal scale. You can't put them on a scale of moviness. You can't say that, well, the dramatic period piece, that is more moviness than the MCU. And the MCU has more moviness than, say, a documentary. The documentary has more moviness than, something else. You can't say that because, again, it's on a nominal scale. It's impossible to say. Now, you could categorize them and say, well, which ones have higher quality? Which ones have higher critic scores? You can do that. But the genres themselves cannot be an argument or be used as a scale for what is or what is not, or what does or does not have moviness. All right, so in that case, we already kind of mentioned this. What kind of math can you do with these scores? So if you were using any of these scales, what's the kind of math that you can do? What's the kind of statistics you can do, analysis that you can do with these scores? And the answer is none. You can't do any math. Nominal scales do not allow you to do any math. So if somebody is using a nominal scale and they tell you that they calculated the average of all the scores, your first question should be, how the heck did you do that? Because you really can't add categories together. And your second question should be, well, it's not a question, your second statement should be, you're not allowed. That just does not or cannot be done. So that's important to know, because as we're going to see as we go into higher scales, the temptation to do math is there, but it's false, it's not allowed, and we need to be able to think about it to make sure that we're not doing what's not allowed. All right, ordinal scales. Ordinal scales are one scale up from a nominal scale, and each subsequent scale is one scale up from the previous scale. And what that means is that each subsequent scale can do everything that the previous scale can do, plus one more thing. So whenever you're analyzing, is a particular scale one of the four types, always start with the least, with the lowest level scale, the nominal scale. Ask if it fits the nominal scale category, then ask if it fits the ordinal scale category, and keep building up until it no longer satisfies those criteria, and you'll figure out what scale it's at. Because the ordinal scale, the next step up, can do everything that the nominal scale can do. It has different categories. But now, kind of spoiler alert, you can also rank the categories. You can put them in order. So an ordinal scale, you can make the categories, you can identify different categories, but then you can also rank those categories. Now you can actually say, this one has more of this. This one has more of what we measured than this other category. So one of the classic ordinal scales are any movie rating systems that are measuring movie quality, right? So a movie rating system will measure movie quality. So a critic will go see something like Transformers: The Last Knight, aka the movie that put the final dagger into the Transformer universe. We have The Mummy from last year, Tom Cruise's The Mummy, movie that killed the entire Dark Universe expanded universe there. And then we had Atomic Blonde with Charlize Theron, female-led action noir. And then also, I think a couple years ago, we had Wonder Woman, big, huge success, critically acclaimed. So we have those four movies. And critics will use measurement scales to put those four movies into an ordinal scale in terms of quality. What they're measuring is movie quality. So what might that look like in our types of measurement scales? Well, in the measurement scale itself, one of the classic sort of movie measurement scales is the star system, right? So we got a 1-star movie, we got a 2-star movie, we got a 3-star movie, and we got a 4-star movie. And what they'll do is they'll basically assign different movies, different stars based on their quality. So Transformers, and these true scores are from Rotten Tomatoes. Transformers, very low score. It was a 1-star movie, indicating low true quality of the movie. Wonder Woman, 4-star movie, indicating high true quality of the movie. Tom Cruise's The Mummy, low quality movie, 2-star movie, which again indicates low true quality of the movie. And then we have Atomic Blonde, that was a 3-star movie, again indicating higher quality of that movie. So notice that you put these movies in order. So we have an ordering to them. So with this ordinal scale, you can say that a 3-star movie has higher quality than a 2-star movie. You can say that Atomic Blonde, that movie's true quality is better, is higher than Tom Cruise's The Mummy. And I know that movie quality is subjective, but again, we actually have the true scores represented here. So we're imagining that these movies actually have a sort of, if an omnipotent force came down and said, I judge these movies to be like this, basically that's what we're looking at, their true score. So you can put these in order, that's an ordinal scale. But we cannot do other things with this. And one of the things that we can't do, and this is really tempting to do with this type of a scale, is you can't take averages. You cannot take averages with this ordinal scale. And the reason that it's tempting is because the ordinal scale oftentimes is represented in numbers, right? So we got a 1-star movie here. We got a 2-star movie here. We got a 3-star movie over here. We got a 4-star movie over here. And you might ask yourself, well, if I'm asking about the average quality of these two movies here, couldn't I just take 1 plus 2 and divide that by 2 and we'll end up with 1.5? Can't I say that those two movies on average have a quality of 1.5? And while you can plug that into a calculator and spit out the answer, your answer makes no sense whatsoever, because the 1.5 that's between there is not between these two movies in your true score. So this true score here is on the measurement scale a 2-star. This true score here is on the measurement scale a 1-star. Their true middle is not 1.5. It's about 1 3/4 here. Sorry, it's about 1 1/3 here. So you can, on your measurement scale, find the middle of your measurement scale, but it does not line up with the middle of the true score. So if you take averages with an ordinal scale, you will bias the results, you'll skew the results, you will basically incorrectly and falsely represent what your true scores are. And that's one of the important things to keep in mind for the ordinal scale. Because while you would be completely correct in saying, oh, Wonder Woman, 4-star movie, 4-star is better than 3-star, Atomic Blonde, 3-star movie, Wonder Woman is better than Atomic Blonde. Notice, 4 stars greater than 3 stars, Wonder Woman greater than Atomic Blonde. The measured scores reflect the actual truth. Middle of the 3 stars and 4 stars, not the middle of the actual quality, it's over here. So taking the average of these scores does not represent the actual truth. So you always have to be very careful when you see people starting to take averages. It can skew results and lead to misinterpretations of what's really going on out there. All right, so that's the ordinal scale. So typical examples, things we just saw, movie rating system. You cannot add up the scales that movies have been given and then take an average, for example. That's not allowed. Restaurant rating systems. This is a great one that we hopefully have not all experienced, but you'll hear about, ooh, this is a 5-star restaurant, this is a 4-star restaurant, 3-star, 2-star, 1-star. Your experience in a restaurant like that, that's what the restaurant rating scales are trying to tell you. They're basically trying to tell you what your dining experience is going to be like. And the difference between a 5-star and a 4-star. A 5-star restaurant, you'll have the experience of your lifetime, right? It's going to be a great dining experience. A 4-star restaurant, slightly less, right? The difference between 5-star and 4-star, not that big, right? Not that huge of a difference. So we got a 1-star difference that is a very small drop in the quality of your dining experience. If you've ever gone to a 2-star restaurant compared to a 1-star restaurant, 2-star restaurant, you're not going to enjoy the food very much. It's going to be kind of bland. It's not going to be great. Not going to be a good dining experience. Take 1-star below, you end up in the hospital with food poisoning. All right? Huge drop in your dining experience from a 2-star restaurant to a 1-star restaurant. So very small drop from 5-star to 4-star. Huge drop from 1-star to 2-star. And it's still 1-star difference. But that 1-star difference means different things at different points in the scale. That's why you can't take the average. So restaurant rating systems, any top X lists, top 10 lists, top 5 lists, the difference between first and second place might be razor thin. The difference between second and third place might be super huge. So we see this in the Olympics all the time, where the first place finisher just barely beats out that second place finisher. And third place is all the way back here, trying to get that bronze medal. There's no difference between, in terms of the steps on the scale between first and second, second and third. It's a 1-step difference on the scale. That does not translate into the same difference in the actual true scores. So you cannot take the average of those. You can't say that, oh, the silver medal time was the average of the gold medal winning time and the bronze medal winning time. That's not going to be the case in most situations. All right, let's get into psychology. Likert scales. Likert scales are the subject of much debate because at their core, Likert scales are an ordinal scale. So they are, on a scale of 1 to 7. How well do you think you performed, on your test? 1, not very well. 2, slightly not well. 3, neutral. 4, I did well. 5, I did extremely well. Those you can rank in terms of the order. You can say that, yes, doing poorly is going to be lower than doing neutral. But as you probably experienced with Likert scales, they do averages of Likert scales all the time. There are many psychological tests where they take the sum of all your answers on a Likert scale, and then they take the average of those. And that is not necessarily true, right? So the difference, and you can see it this way, the average of somebody, let's say that we had a scale that had to do with customer satisfaction, right? Somebody that replied 5 out of 5 for the first series of questions and 1 out of 5 for the final series of questions, right? Say there were 10 questions. For the first 5, how prompt was the response? 5 out of 5. How helpful was your customer associate? 5 out of 5, right? 5 out of 5 for the first 5 questions, 1 out of 5 for the last 5 questions. You take the average is going to be 3 out of 5 for the entire survey. That person had a much different experience than somebody who has 3 out of 5 all the way down. What was the response time? Average. What was the friendliness? Average. How helpful were they? Average. So it's a completely different experience, but you take the average of those two Likert scales and it ends up with the same average. So you cannot take the averages of Likert scales, and you will notice time and time again in your psychology education, people will do that over and over and over again. Now, one of the things that I'll mention for ordinal scales here is that you'll see that, and when you go to grad school, if you take psychometrics, which is the study of measurement scales as applied to psychology, there are justifications for why you're able to do the Likert scale that go beyond the scope of this course. But just know that as an ordinal scale, it does not qualify for things like taking averages. So if you ever come across a study that uses Likert scales, their results can be called into question if they take averages, which again, most of these studies do. All right, any questions on ordinal scale? Okay, so what kind of math can you do with these scores? The answer is you can order them. So you can do the mathematics of putting them in order, right? Saying that this one comes before this one is greater than this score is less than this score, and that's it. That's all you can do. Can't take averages, can't add them all up, can't do that, not allowed. All right, interval scale. Interval scale can do everything an ordinal scale can do. Categories are different. Can rank the categories in order. But now we have that the intervals between the categories on the measurement scale are the same as the intervals between the categories in the true score. So that's what they mean, intervals between categories are constant. What they're saying is that the intervals on your measurement scale are the same as the intervals on your true score. So interval scales are oftentimes confused with ordinal scales. And if you get those two confused, specifically if you're looking at a psychological tool like Beck's Depression Inventory, and you're asking yourself, is this an ordinal scale or is this an interval scale? Some of them are confusing, and just be aware that it's beyond the scope of this course. There are people with PhDs who dedicate their life to psychometrics, who are trying to determine what scales that we use are interval scales, what scales do we use that are ordinal scales. So just make sure that you get a firm grasp of the concepts behind it. But there is one very clear interval scale that is well known, and that is the scales that we use for measuring temperatures. So temperature, there is a true temperature out there. So temperature is an actual physical thing where it's literally the speed of the molecules and how much they're vibrating and moving. The more they're vibrating, the higher the heat. The less they're vibrating, the lower the heat. So there's an actual physical amount of temperature out there. And here we have a winter's day, here we have an autumn day, and then here we have a warm spring day. You can measure temperature. And there's two widely used interval scales that measure temperature. So here we got Fahrenheit, and here we have Celsius. And you can measure that winter day, and you can measure that autumn day, and you can measure that spring day. And notice that that winter day, which is about minus 10 degrees Fahrenheit, that is here in the true score, and it's here on the measurement scale. And this is the first time that when we measure a second temperature, this autumn day that is 50 degrees, this is the first time that the distance between the true scores is reflected in the distance on the measurement scale. This distance here is the same as this distance here. So this big difference between the winter's day and the autumn day is represented by a correspondingly big difference on the measurement scales. And this smaller difference between the fall day and the warm spring day, the true difference, is represented by a smaller difference between those two on the measurement scale. So that leads to this one-to-one parallel structure, and that's what makes an interval scale an interval scale. It's when there's a small interval in the true scores, there's a small interval on the measured scale. When there's a large interval between the true scores, there's a large interval between the measured scales. That's what makes an interval scale. So on an interval scale, we have those three features. Examples of interval scales. The only real clear example is Fahrenheit and Celsius. I think in all of science, that's the only one where everybody's like, that for sure is an interval scale. And that's why I got question marks here. So personality measures, they seem like interval scales. It seems like we have that talk coming up. Is everyone a psychopath? Right? I think it's today at 5:30, if you want to head on out there. But if there's a measure for people for psychopathy, you can give them a scale. Somebody who scores very low, we assume that they're low in psychopathy. Somebody that scores very high, we assume that they're high. That's an ordinal difference. Somebody that scores slightly higher on the scale, we assume that they're slightly higher in psychopathy. If the intervals on the psychopathy scale match up with the corresponding intervals in terms of the true amounts of psychopathy, then that personality measure would be on an interval scale. And like I said, there are people with PhDs who dedicate their careers to trying to figure this out, that argue about whether personality measures are interval or ordinal scales. So again, focus on what the scales entail, and then in your career, if you're wondering, is a personality measure an interval or ordinal scale, just know that you're not the only one wondering. Intelligence test, IQ scores. You will hear people taking the average of IQ scores all the time. You'll hear things like the Flynn effect, which is that the IQ scores of today's students is actually higher than it was decades earlier. So if you take the same IQ test from the 80s and give it to people now, they will score higher than the people that did it in the 80s. And they will say things like the average score today is higher than the average score in the 1980s, indicating that they believe an intelligence test is on an interval scale. Whether or not it is, again, that's up for debate. So what math can you do with these scores? Well, the answer for this is you can order the scores. So once again, everything we could do with the previous scales, we can do with the new scales. So you can say 30 degrees Fahrenheit is colder than 50 degrees Fahrenheit. We can put those in order. 50 degrees Fahrenheit is then colder than 80 degrees Fahrenheit. You can put them in order like we did with the ordinal scale, but now we are also able to take averages. And you can intelligently and correctly say that the average temperature this summer was 5 degrees warmer than the average temperature last summer. You can say things like, oh, this is the warmest October on record. Sorry, that'll probably be September. This was the warmest September on record it beat the previous average by 1 degree. So the average temperature of this September was what, 85 degrees it felt like. The highest average before was 84.5, right? You can say those things and you'd be right. You'd get to the true score of it, you would be correct. So again, if you take an average of, I'll make the math easy on me. If you take an average of 10 degrees Celsius and 30 degrees Celsius, right? 10 plus 30 is 40 divided by 2, that's an average of 20. 20 degrees Celsius should be right between the true temperatures of these two days. And if you take a look at 20 degrees Celsius, sure enough, right between the actual true score. So averages on an interval scale measure the true averages in the true scores. Yep.
I was in my statistics class, my teacher said that if it's pretty much from 0, like on the scale. So for like temperature, would there be no true 0 because like 0 degrees would still be a certain amount of temperature?
Yep. Okay, so yeah, so we're getting to the next and most powerful measurement scale. So the one thing that an interval scale is lacking is that true 0. So this 0 here is not a true 0. And if it was a true 0, you couldn't go minus, right? Because if it was really 0 temperature, you can't go less than 0 temperature. So when we get that true 0, that's when you get the most powerful scales. That's when you can do the most things with it. So for example, one thing that you can't do with this scale are things like ratios. So let's say that we had a Canadian who uses the Celsius scale, and we had an American who uses the Fahrenheit scale, and they were reminiscing about that autumn day that they spent in that vineyard, and that warm spring day that they spent in the field. So they're reminiscing, and they say, oh, well, do you remember that time that we went into that vineyard in autumn, and then we went into that field in spring? You know, the average temperature there was 20 degrees Celsius. And the American would say, oh, yeah, I remember that. The average temperature was actually 68 degrees Fahrenheit. But we both agree that's the same amount, right? 20 degrees Fahrenheit, 20 degrees Celsius, 68 degrees Fahrenheit. It's the same amount. We're in agreement. We know that we're measuring that actual true value. If the conversation continues and the Canadian goes, wow, he goes, remember that spring day, 30 degrees Celsius, and that autumn day, 10 degrees Celsius, man, that spring day was 3 times hotter, right? Because 3 times 10 is 30. So it might say, yeah, that spring day, 3 times hotter than that fall day. Could you believe that? And the American goes, whoa, wait a second. That autumn day was 50. The spring day was 85. That's not 3 times hotter. That's only 70% hotter, right? And the Canadian would be like, no. It's not 70% hotter. It's 200% hotter, right? Because 30 is 200% more than 10. And the American would say, no, you're doing your math wrong. You're not getting to the heart of the matter. It was only 70% hotter. And the Canadian would say, what are you talking about? 10 and 30, totally different. 200% hotter. And you can go back and forth on this over and over and over again. And they will never come to an agreement because they're using their scales wrong. So notice they came to an agreement on the average because you're allowed to do that in the scales. They could not come to an agreement on the ratios because you cannot do that in an interval scale. You want to do ratios, you got to go to a ratio scale. So a ratio scale, most powerful one we got, categories are different, just like every other scale. Can rank the categories in order, just like the ordinal and interval scales. Intervals between categories are constant, just like the interval scale. It's got one more thing, there is an absolute 0. That's the last piece that we need for the ratio scale. And once you have that absolute 0, you can do all the math you want. So what do we mean by absolute 0? Well, in this case, we'll first say what is not an absolute 0. And not absolute zero is when you basically just choose an arbitrary zero. So for example, there is 0 on the Fahrenheit scale. And Fahrenheit, the inventor of the Fahrenheit scale, decided to put his 0 right there. He was making a temperature scale, and he said, I'm going to put my 0 right there. Celsius, when he was making his scale, said, you know what, I'm going to put my 0 right there. So does anybody know why Celsius chose that point for 0? Mm-hmm.
It freezes.
That's where water freezes. So Celsius literally said, I need a 0 point for my scale, and I'm just going to choose where water freezes. And that's why Canadians use Celsius, because that is at least as cold as it needs to be before you can go play hockey on the pond. So that's the one that we use. At least that's the reason I like to think we use it. Anyways, so he chose water freezing. Any idea what this one is? And this might be an urban legend, so you might want to fact check me on this. Apparently, Fahrenheit was developing his scale for refrigerator manufacturers, and that 0 is the temperature at which your ice cream turns rock solid, so it'll break your wrist when you try to scoop it out. So above that, your ice cream will be scoopable. Below that, your ice cream freezes. So that 0 was chosen there as the one where ice cream freezes. So you can double check that fact. It might be an urban legend, but I'm going to go with it. But importantly, both of these are arbitrary, right? You might as well say, oh, well, I'm going to choose as 0 when I feel comfortable in a room. So I'm going to choose 70 degrees Fahrenheit. I'm making a new scale. That's my new 0 right there. If you can do that, it's arbitrary. And once you do that, you don't have a ratio scale. So we do have a ratio scale for temperature. And the reason for that is because there is an actual true 0 for temperature. So once again, as I mentioned, temperature is basically the speed, the average speed of your molecules in your environment. So when it's hot, they're moving a lot. When it's cold, they start to slow down. They start to slow down a little bit. And there comes a point where they can't slow down anymore and they just stop. That's as cold as they can get. That is, you cannot get colder. You cannot get less motion than no motion, right? So there is an actual absolute 0 for temperature. And when Kelvin, there he is, when Kelvin came up with his scale, he said, all right, I'm not going to choose an arbitrary 0. I'm going to choose the real 0. And the 0 that I choose is an absolute 0 amount of temperature. So when all of those molecules and particles stop, that's as low as you can go. So 0 on the Kelvin scale is your absolute, not arbitrary, not artificially chosen, your real 0. 0 on this scale is actually 0 in the real world true temperature scale. So I should have moved these way over there into the other room because absolute 0 is phenomenal. Well, I mean, you can see here, it's like beyond minus 450 degrees Fahrenheit. So you can imagine, you don't want to go outside when it's like minus 30. Multiply that by, 15 and you'll get to here. So anyways, that's absolute 0. And when you are working with scales, such as Fahrenheit and Celsius, which are interval scales, it makes no sense to do ratios. But when you're working with the Kelvin scale, now you can do ratios. So now you can say that 70 degrees Kelvin is actually 40% warmer, 40% hotter than 50 degrees. You can say that 60 degrees is 20% hotter than 50 degrees, and you'll be correct. You will be true. It'll reflect the actual true measures of temperature because now we have an absolute 0. All right, so that is the ratio scale. And examples of the ratio scale, things like Kelvin is on a ratio scale. In psychology, things like reaction time are on a ratio scale. So if you want to measure people's reaction times and you flash a light, and then you see how quickly they can press a button. There's an absolute zero for that, right? If they were instantaneous, then as soon as the light flashed, they could press the button. That's the zero. It's not arbitrary. They don't say, well, we're going to start counting 5 seconds after the light flashes. No, when the light flashes is zero. That's not arbitrary. It's an absolute zero. It makes it a ratio scale. Physical measures, things like height, right? Height has an absolute zero, the floor. The floor is your absolute zero for height. Nobody in the world ever says, you know what, I'm going to measure my height. I'm going to start at my knee and just measure up. And that's going to be my new height. Nobody says they're going to choose their knee as absolute zero. I know a lot of us that are trying to get healthier and might be looking to lose some weight. Nobody can say, you know what, I feel like resetting the zero on my scale. I'm going to set the zero at minus 10. So what used to be minus 10 is my new zero. And lo and behold, I'm 5 pounds lighter than I was before. If you understand that as gaining 5 pounds, well, there you go. Anyways, so physical measures have absolute zeros. One thing that I will mention right here that's very important to remember when you're evaluating different measurement scales is that you always start at the bottom thing that can be done, and you go higher and higher until you figure out what category you're at. And the reason you need to do that is because there are certain scales that have an absolute zero, but they don't have, for example, intervals between the categories are constant, right? So you can get an absolute zero without constant intervals between them. So for example, in a movie rating system, you can have a zero quality movie, right? So a movie that's just, I don't know, a blank screen for an hour and a half. You can say that's a zero quality movie. And most people would say, yeah, that's absolute zero in terms of movie quality. But that doesn't all of a sudden mean that your movie quality ratings is on a ratio scale, because they're still missing this one. So they need to have everything in order to be a ratio scale. And sometimes there's an absolute zero without this, and people mistakenly say, oh, there's an absolute zero, it's a ratio scale, because that's what it's known for. Not the case. You need all four of those before you end up with a ratio scale. And the maths that you can do with this, well, you can do ordering, you can do averages, and now for the first time, you can do ratios. Basically, all the math opens up to you in this case. All right, so those are the 4 different types of measurement. And again, as psychologists, we're trying to get to the truth. We're trying to get to these true scores. As psychologists, all we have access to are these measured scores. So it's very important to identify what measurement scale you have, because if you do certain things with certain scales, it might look like you're getting to the truth, but you'll be missing the actual true scores. So if you take averages with an interval scale, you're fine. If you take averages with an ordinal scale, you could be vastly misrepresenting what the true scores are. So it's always important as critical thinkers to think to ourselves, is it a nominal scale, ordinal scale, interval scale, or ratio scale? And depending upon what scale they are the researchers using these scales correctly? All right, so any questions on that? Yep.
I might just be overthinking this,
Mm-hmm.
but so like for Fahrenheit and Celsius,
Mm-hmm.
are they only interval scales because like there's no absolute zero?
Yes.
Because like what if you had a conversion factor where you could like make them the same? Would that still be considered interval? Because there's technically no true zero. I think I was overthinking it.
You might be overthinking it. If you convert these scales so that they have a true zero, like an absolute zero, a real zero, then basically they'll just be scaled version of the Kelvin scale,
Okay.
right? So you could definitely convert Fahrenheit into a scale with a true zero, and that's what we see right here. So minus, 467 Fahrenheit is actually zero. But you can't do math with the scores from a Fahrenheit scale because the real zero is being represented by minus 467. If the real 0 is being represented by 0 on your measurement scale, then you have an absolute 0, you have a true 0. So they come close, right, because they do have those equal intervals, but they're missing that true 0. All right, any other questions, comments about the measurement scales? All right, so that is what I wanted to cover for today. So next time we meet, we will be doing our exam, so that's the only thing we're going to be doing on that day. And we are now at the point in this course where there's a bunch of moving parts. So for example, I'll have more to say about the method section review, the peer review after the exam, because I want you guys to be able to focus on the exam. But just take a look at your syllabus, be aware of all these things that are coming due, things that you should be working on, because right now there are a lot of moving parts that are in the syllabus, so just be aware of that so that you can maximize your performance in the course. Other than that, we're done for today.